Good day, everyone. I am Jessama Sparsha, and today I will discuss on how to get the determinant of 2 by 2, 3 by 3, and 4 by 4 matrix. Okay, so to find the determinant in 2 by 2, suppose we have the given 3, 2, and 1, 4. So to get the determinant, this is so very easy because we're just gonna multiply the diagonals minus this minus the other diagonals. So so 3 times 4 is equal to 12. This one we obtain 12 minus 1 times 2. So we have 2. So this is equal to 10. So the determinant is 10. So we have another example, 7, 2, 4, and 3. So again, we have to multiply 7 times 3. This one minus 4 times 2. So 7 times 3 is equal to 21 minus 4 times 2 is equal to 8 is this equals to 13. So our determinant is 13. So as you know, 2 by 2 matrix and getting the determinant is so easy to obtain since you just need to multiply the diagonals to each diagonals. Now, let's proceed to the 3 by 3 matrix. So, we have this given 8 as A1, A2, A3. We have A4, 8, 4, 3. Then the second row is negative 5, positive 6, and negative 2. And then the third row is 7, 9, and negative 8. So first, we need to copy the we need to copy the matrix below, and then this is the copy below. So to obtain this is the XYZ. Then to get or to solve this one, we will multiply diagonally, like just like what we did in the 2 by 2 matrix. So 8 times 6 times negative 8 plus 4 times 2 negative 2 times negative 7 plus 3 times negative 5 times 9. So and minus the other side, 7 times 6 times 3 minus 9 times 2 times 8, and then negative 8 times negative 5 times 4. So through calculating this one, we will obtain the answer negative 384 minus 56 minus 135 minus 126 plus 144 minus 160. So in further solving, we will get negative 861 plus 144. And we obtain negative 717. And so we have our determinant for B, we have obtained the negative 717. So another given, to give you another examples, we have the given negative 1, 2, 7, 2, negative 1, negative 1, 3, positive 5, and 2. So again, we just need to first calculate this first column. So our first leading minor is we have negative 1 times negative 1 is positive 2. Positive 1 times positive 2. So that is, the answer is a positive 2. Plus, uh, plus 2 times 5 times 7 is we have 70 minus 3 times negative, we times 3 time, I mean, minus 3 times negative 1 times 2. So we obtained negative 6 plus to the other side, we have 3 times negative 1 times 7 is equal to 21 minus um, minus 5 times negative 1, I mean, yes, it's 5 times negative 1 times negative 1, and that is negative 5. And then last one is 2 times 2 times 2. So that is minus 8. So through calculating this one, we obtained 93 minus 19. So the answer is 74. So our determinant is 74 for this matrix. So now, since 3 by 3 matrix is clear to you, we will now go down to 4 by 4. So 4 by 4 matrix is very tricky because we will have another way, not really quite different from the other, but there are solutions that are not included from before because again it is already 4 by 4 matrix. Okay, so suppose we are given this matrix. The first row is 0, 0, 4, and 6, 2, 1, 1, 3. The third column is row is 2, 1, 2, 3, and the last row is 3, 0, 1, 7. So what are we gonna do first? First, we are going to copy that matrix 6 and then solve that matrix. So to solve that one, um to solve that, I'm gonna show you on how I obtain that. All right. So this is our first leading term. And then we have to cover this first column and then the first row. And then as you can see, these remaining numbers, that is what we're gonna write in there. As you can see, right? And then how do we, so now we have 1, 1, 3, 1, 2, 3, 0, 1, 7. And and now we will solve this matrix. Same as the first 3 by 3, 2 by 2 thing, right? So to get this, we have 1 times 2 times 7 is equal to 14. This one, yes. And then we have 1 times 1 times 3. And then we have 0 times 3 times 1. That would equal to 0. So we have 14 plus 3 plus 0. So, all right. And then we need to go to the other side. So again, we have 0 times 2 times 3. We obtained minus 0 minus 1 times 3 times 1. That is minus 3. And then the last one is 7 times 1 times 1. All right. So to solve this, we obtain so we have 14 plus 3 plus 0 minus 0 minus 3 minus 7, and then we obtain 17 minus 10. So the answer would be 7. Now we need to solve this by using, I mean, by using I'm sorry, by using the basic basis. We have the negative 1 column, first column end and times row end. So yeah, so that would be 0 times negative 1 to the um, negative 1 squared times um, 7 is equal to 0 times 7. So that would be equal to 0. This 7 is, we input this 7 we get this from our answers. So that's why we put 7 here. So to calculate this, we have obtained 0. So that is our first minor. This is our first minor. This is equals to 0. Now we proceed. All right, so let's proceed. Again, um, with the same given because we're not finished yet. So we have to copy again the matrix and then to cover this one, to cover the second row and the second column. So this remaining, this remaining, we have, I'm sorry, we have 2, 2, 3, and then 1, 2, 1, 3, 3, 7. We have to copy that again, and then the same solution to multiply that, we multiply diagonally 2 times 2 times 7. We have 28 plus 2 times 1 times 2 times 1 times 3. We have 6 plus we have um we have um 3 times 3 times 1 is equal to 9 minus 3 times 2 times 3 18 minus 1 times 1 I mean 2 times 1 times 3 is negative 6 minus um minus 14. So that would be equal to 5. Again, from our bases, we input 5 from our answers and then calculate that one. So 0 times negative 1 times 5. And that would be equal to negative 5. So don't forget that our first solution is 0 and then our second solution is negative 5. So next, let's get the third minor. So we have to cover this, and then that. So our remaining would be 213, 213, and 307. Copy that, and then the same solution again. Multiply it diagonally, and then the two pairs, you will just get another from here or from here, so that you can. So this is the solution from our when gonna solve this matrix, we have the solution 14 plus 0 plus 9 minus 0 minus 14. And again, our our answer is 0. And then we're gonna input this in our basis. So we have 1 times negative 1 to the fourth power, and then 0 is equal to 1 times 0, and then we obtain 0. Again, we have 0, negative 5, and now 0. So down to the last one. So we have to cover first row and last column. So the remaining numbers, we have to copy it and then solve it by multiplying diagonally. And then we will obtain a solution 2 plus 0 plus 6 minus 3 minus 0 minus 2. That would be equal to 3. And again, we need to input it in our basis. Yes, in our basis. Input it in our basis. So we put 3 here and then um, so we will get 6 times negative 1 to the fifth power times our answer 3. And then we will, by substituting 3 on each and by solving it, we will obtain negative 18, right? So thus, um, our determinants from first to fourth is 0 plus 0 plus 0 plus negative 18. Our determinant should be negative 18. All right, so thank you very much for watching. I hope that you've learned a lot from my videos discussing on how to get the determinants of 2 by 2, 3 by 3, and 4 by 4 matrix. And this is very important when you are asked to do the inverse or the Kramer's rule of solving linear equations. Thank you very much for watching, and I hope you've enjoyed a lot.